Hello, everybody. Yeah, welcome to section number 3.3. And here we looked at 3.2 in our previous section, which was 3.2. Under this section, we're going to be looking at subtraction of whole numbers, right? So we looked at the various properties of addition in 3.2, all right? And we looked at addition of number bases. And here we're going to look at subtraction mainly of whole numbers, all right? And this is a pretty short section. Okay, nice. So let's get into it. So these shall be our objectives, and we'll run through as we can. Now, subtraction of whole numbers can be modeled in several different ways. We have what we call the takeaway model, right? And here again, as well, we look at the number line model, where we look at number line representation, and we shall take these one after the other. All right, and what we call the mixing Addend model, okay? And we shall look at that as well. And that is, this model is what has been developed into find x, okay, find y. 3 plus x is equal to 3, find x, and all that. Okay, now here, what we call the takeaway model. So here we have 8 blocks, and if we take away 3, we have what? 5 left. So basically just taking away. Now the number line model, when we looked at the addition model, I said that when you move to the right, you are adding, and when you move towards the left, you subtract, right? So we have 5 minus 3, so we move 5 times to our right. So 1, 2, 3, 4, 5, and then we move backwards. 1, 2, and 3, okay? And that should give us 2. So we have 2 right there. And that's how the number line model works. Okay. Nice. Now let's look at the next. And here what we call the missing addend. So 8 minus 5, 8 minus 3 should give us 5. Okay, so in effect, what number do we add to 3 to give us 8? And that is 5. And that's what we call what? The missing addend. Okay, now missing addend, okay, subtraction of whole numbers is same approach set up right here. Now, definition of subtraction of whole numbers. It says that for any whole numbers a and b such that a less than a greater than or equal to b, a minus b is a unique whole number. C such that b plus c is equal to what? A. Is that okay? And that is how subtraction really works. Nice. So a minus b is equal to c, and at the end of the day, so really this is all we mean. A minus b is equal to c, and at the end of the day we say that a is equal to b plus c. Okay. Now we have what we call the comparison, subtraction of whole numbers, and the comparison model. So here you're trying to compare, and you find a difference. So difference means subtraction, okay? And that's what we do here. Nice. And then here we also look at, so that we already looked at that. Now properties of subtraction, it can be shown that a less than b, then a minus b is not meaningful in the set of whole numbers. Therefore the subtraction is not closed under the set of whole numbers. Like I described to you, when we say something is closed, now a minus b, it depends on the value of the numbers. So now if my a is say 2 and my b is 5, what is my result here? My result right here is minus 3. Now minus 3 is an integer, it's not a whole number. So we say that minus 3 is not closed under the set of what? Whole numbers. So closure, therefore subtraction is not closed on the set of whole numbers. Okay, subtraction is not closed on the set of whole numbers. Now, introductory algebra using whole numbers, and we know these, okay? Now, this is where I'm sure students will appreciate this better when you use something like the sunlight, the morning light. We have a diamond and all that, all right? And this is where when you grow up to college, you change everything, and now they represent those by X and Y's, okay? So, sweet. And we have looked at the concrete model and how you can, now here, you just subtract, okay? So just like we did in the other section, the concrete model, like we did in the addition, you just add and subtract. Now, equal additions algorithm. Now, what this means is that when you're adding two numbers, or when you're subtracting two numbers, and you add the same amount of number to the two numbers that you are adding, the resultant will not change. Is that okay? The result wouldn't change. So here we added 7 and 7 and 30 and 30, and the result, our outcome will not change because we have added the same numbers, the same number to both numbers. So that will not change, okay? And counting up algorithm, you can look at the counting up algorithm and how that works. So this is the instructions, how you go about using the counting up algorithm. It works more like the counting on algorithm we looked at and the additions. Is that okay? And this is an example of the counting up algorithm. Okay. Now here, Noah owed this, and this is how you can, how much change did Noah receive? And at the end of the day, you will realize you come up with the subtraction, and Noah should receive a change of $39. Okay, nice. Now trace first algorithm, and this is the instructions you have to go through to get to the trace first algorithm. So these are teaching techniques, ways to subtract that you can adopt, and that will help the kids to appreciate mathematics better. Is that okay? Nice. Now here, this is where I feel you need some explanation, more explanation on this. Now we are subtracting in base what? 5. Now this is the addition table we looked at in section 3.2, but this time you're going to subtract. And look at it closely. So we have 4, 3, 2, base 5. And then we want to take away 43, base 5. Now, we are subtracting in base 5. So 2 minus 3. 2 minus 3. Now, because we cannot do that, we have to borrow from here, right? And this will be, so now, any number you borrow is 5 because you are subtracting in base 5. So we'll be left with 2 out there. Goodness, what's happening? We'll be left with 2 out there. And because any number you borrow, so here we borrowed 2, we borrowed 5. And this is going to be 7. So 7 minus 3 gives us what? 4. Now we already have 2 there. So 2 minus 4 will not work. So we have to borrow. So we are going to borrow around from there. And any number we borrow will be what? 5. So this is going to be 5 plus 2, which is 7. So 7 minus 4 is what? Is 3. And then finally we have 3. So our result is 334 base 5. And that's how you subtract. So any number you borrow is the value of the base. So if it was a base 2, if you borrowed a number, if you borrowed 1, it will be counted as 2. If it was a base 8, you borrowed 1, it will be counted as 8. Okay, nice. And that is how this is a further breakdown of the takeaway model. And here we look at the various mental computation methods: breaking up and bridging, trading off, drop the zeros. And basically, that is all we have to look at under these sections. Okay, this section 3.3. So thank you very much for your time, and I'll see you again. Thank you. Bye-bye.